Welcome. In today's video, we're going to be taking a look at arithmetic progressions. So what exactly is an arithmetic progression? Well, an arithmetic progression is a sequence of numbers such that the difference between consecutive terms in that sequence is constant. So for example, if we consider the sequence of numbers 5, 7, 9, 11, you'll notice that the difference between each consecutive term, so here for example 5 and 7, that difference is 2. Then between 7 and 9, the difference is also 2. And 9 and 11 difference is 2. And so if we were to continue this pattern, we'd see something like 11, 13, 15, and so on. We say that this is an arithmetic sequence with a common difference of 2. Similarly, let's take a look at the sequence of 20, 17, 14, 11. You'll notice here that this is actually decreasing by 3 in each step. So we actually say that it has a common difference of -3. So this is an increasing arithmetic sequence. This is a decreasing arithmetic sequence. So we're going to try and formalize the notation a little bit here. So let's suppose that Tn, T subscript n, denotes the nth term in the sequence. And let's call D, let's say D is the difference between consecutive terms, and A is the first term in the sequence. So what we'd have something like is the first term, T1, would be A. The second term would be A plus D. The third term would be A plus 2D, so a further D difference from the second term. The fourth term would be 3D, and so on and so forth. So in general, what we say is that the nth term in the sequence can be written as T subscript n A times n minus 1D. Now, where does this n minus 1 come from? Well, just having a look here, when we have T4, we have 3D. So here's 4, here is 4 minus 1. Here is T3, here you've got 3 and you've got 2, so it's 2, 3 minus 1. So in general, it looks like Tn is equal to A plus n minus 1 times D. Let's have a look at a bit of an example of how we might use this mathematical notation. So the first term of an arithmetic progression is 3, and the seventh term is 15. Find the 10th term and common difference of the sequence. That's part 1. And then part 2 says the fourth term of an arithmetic progression is 12, and the 8th term is -20. Find the first term and common difference of the sequence. Okay, well, let's have a look at part 1. So in part 1, we're told the first term of the arithmetic sequence is 3, and the seventh term is 15. So we can write this in our mathematical notation as T1 equals 3 and T7 equals 15. Now, if we let Tn equal A plus n minus 1 times D, then what we have is from the first equation, we get A is equal to D. Sorry, A is equal to 3. And from the second equation, when we substitute 7 in here, so you get 7 minus 1, we have A plus 6D is equal to 15. Solving for D, so we've already found A, now we just have to substitute this information for A in the second expression. So we substitute in 3 plus 6D is equal to 15. Rearrange, that gives us 6D is equal to 12. And finally, D is equal to 2. Now finally, what we had to do is we had to find the 10th term in the sequence. And so the 10th term, again, if we use this general formula here, we get 3 replaced with A, 10 minus 2 replacing n minus 1, and 2 replacing D, of course, because we found it just above here. And that gives us that the 10th term is 21. Let's now take a look at the second example. In this second example, we were told that the fourth term of the arithmetic progression was 12, and the 8th term was -20. So we can write this in the form or the notation T4 is equal to 12 and T8 is equal to negative 20. And remember, if we let Tn equal an minus 1d, then we get two simultaneous equations from these two expressions above. The first being when we substitute in n equals 4, we get a plus 3d is equal to 12. And then when we substitute in n is equal to 8, we get a plus 7d is equal to negative 20. Now, we can solve simultaneous equations two ways, either one through elimination or substitution. Now in this case I've got an a here and an a here, so I know if I subtract these equations from one another, those a's are going to cancel out, and so I'm more likely to, or I'm more inclined to use elimination, and that's exactly what I'm going to do. So I'm going to take equation 2 and then I'm going to subtract equation 1 from it. And that gives me 7d minus 3d, which is 4d, and negative 20 minus 12, which gives me negative 32. Then, of course, dividing both sides by 4, we get d is equal to negative 8. And finally, we need to also solve for a. And so substituting in this piece of information, d is equal to negative 8, into the first equation up here, we get a plus 3 times negative 8 is 12. And solving for a, this gives a is equal to 36.